Didn't see you there. Come on.
This is just going to be so fun.
Welcome to my crib. Today, I will be teaching you how to do question 7. So, I know we all get different values, but don't worry. Even though yours might be different from mine, you can still use this process to calculate it with any of your values. So let's just read out the problem. In a case study in which the maximal rates of oxygen consumption in milliliters per second of 9 species of mammals were plotted against body mass in kilograms on a log-log plot using logs base 10. Now, so far we know that we are on a log-log plot, and that means that our function is in the shape of a power function. So what I like to do is first write out the format or the equation of a standard power function, and that is y equals cx to the power of p. Obviously, these are all just constants, c and p, and yeah. So now, let's keep reading. Oh wait, also, you know that body mass is on the x-axis, and oxygen consumption is on the y-axis. So obviously you have to remember that we're not on x and y axis basis, but we're on log x and log y. So I'm just going to draw out just the graph without the actual function on it, just a graph. So it'll be right here. Ta-da! And I'm sorry that my handwriting is not the best, but you get the picture, you know. So yeah. Now we keep reading the question, and it was found that the data points fell on a straight line with slope approximately equal to 0.83 and a vertical axis intercept, which is the y-intercept or the log y-intercept, of approximately 0.15. Find the formula of the maximal oxygen consumption in terms of body mass. Okay, so we know that this is a log x and log y graph. So we're gonna write out y equals mx plus b, which is the standard format for a line graph or linear graph, you know. So yeah, and I know that on the question it does say let m denote body mass in kilograms. Please don't get confused. I will be using y equals mx plus b, even though here the m will mean slope and x will just mean the x-axis. So yeah, so let's write that out. Y equals mx plus b. Now, since we are on the log y, log x graph, I'm sorry I keep repeating that, but it is really important. We want to substitute y and x for log y and log x in the formula. So that'll mean that we have log y equals m log x plus b. And then we put in the information that we know. So that is, we know that the slope is 0.83, so we do log y equals 0.83 log x plus, and now we put in the y-intercept because b on a linear function means y-intercept. That's also called the vertical axis intercept, and that is 0.15. So now we have our standard linear equation, and we want to convert that into the power equation. And we know what that is. That is y equals cx to the power of p. So the first thing that you want to do is to get x and y on, or get both logs on the same side. So what you can do using your log laws is make 0.83, which is the slope, a power of x, since it is being multiplied by log x. So we have log y equals log x to the power of 0.83 plus 0.15. And then we take the log x and we put it onto the log y side of the equation. So we subtract it. Log y minus log x to the power of 0.83 equals 0.15. Now, what we can do using our log laws again, these are very important, and I suggest that you write them down in your notebook because it's always very helpful to go back to them at any time that you need. Right, what we can do is we can combine these logs. So we do log y divided by x to the power of 0.83. And that equals 0.15. So now we want to get rid of the log because we want it in the format y equals cx to the power of p. So never forget the format that you're trying to get it into because we want it to be a power function at the end. So we log both sides. So that cancels out the log on this side, and we have to log 0.15. To log 0.15, you can just put it in, using your log laws, you can make it 10 to the power of 0.15. So we have y divided by x to the power of 0.83 equals 10 to the power of 0.15. Now we want to take the x and multiply it by 10 to the power of 0.15 because we want to get it onto the right side of the equation to get it back into the format of the power function. Never forget. Okay, so that means 10 to the power of 0.15 times x power of 0.83. And there you go. That is our power function format. Oh, right. And then right in here, don't forget that x is actually m because they want us to denote the body mass, which is the x, as m. So your final equation will be y equals 10 to the power of 0.15 times m to the power of 0.83. And there you go. That's how you do it, folks. Stay sharp, ladies. So I realize that this is a bit confusing, but I put all my working out here, so just let me know.